Hello everybody, welcome back. Today we're going to be going over 10.2.5 and we've only got a few sections left here before we are done with the entire year. So today we're going to be deriving the quadratic formula and we're going to be taking a look at imaginary numbers once again. Alright, so let's just jump right into it. We're going to look at 10-74. We're going to see how they came up with this equation of the quadratic formula. So you remember the equation by now, right? It's right there. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. But how do we get that? It's not just some made-up equation that just someone made up. There's a perfectly good explanation of where this equation came from. And that's what we're going to do right now. Go ahead and write down this problem, the standard form of ax squared plus bx plus c equals 0. And as you're doing that, I want you guys to write that on the left side of your paper. And then maybe try to fold your paper in half vertically so you have a left and a right side. So on the right side, you're going to write the steps of what we did. Okay? So let's just take a look here. So we are going to solve for x, right? Just like a regular quadratic formula, we're solving for x. So if I have this equation right there, if I'm going to solve for x, the first step I want to do is get rid of c. Get rid of that c, I'm going to subtract c on both sides. And that's what we did right there. Okay, so some of these steps that's written in CP/M is not as obvious, and they did that on purpose because they want you to figure out what the steps are. So if you want to go through this and try to figure out what the steps are right now, you can pause the video and see if you can understand every step. If you don't want to do that, you can just follow along because I'm going to go over the steps right now. Okay? Again, so we subtracted c on both sides. And so the next step is, well, if I'm going to get x by itself, I got to get rid of my a value, right, my leading coefficient. So then we divided every single term by a. Right, so if we divide it by a, we're going to get this right there, step number 2. Then step number 3 says, if we drew a generic rectangle and were to factor this, what would go in those two squares? And if you recall, at this point, we are going to complete the squares. And to complete the squares, essentially what you're doing is you're taking your b term, okay? To complete the square, you take b over 2, and then you square it. Remember, you add it to the left side of the equation, and you add it to the right side of the equation. So you're going to ask yourself, well, what's our b value right now? Our b value is a positive b over a. So if I take b over a, and I divided it by 2, right? Well, if I divide it by 2, I'm really just multiplying it by half, right? And then I'm going to square it. Well, what do I get? I get b over 2a squared. And when I square that, remember everything inside the parentheses gets that second power. So essentially I will have b squared, sorry, that's a b, over 2 squared is 4, and then a squared. So I'm going to add this right there to both sides. A b squared over 4a squared. Okay, and that's essentially, when I add it to both sides, well, when I add it to the left, right, I get a perfectly completed square. And it's a perfect square trinomial. Okay, and what CP/M did is they technically added it to the right as well, and then, but then they subtracted it and they wrote it on the left. I'm not quite sure why they did like that, to be honest. I'm sure there's a good explanation for it. I just can't think of any right now. So what they're going to do in the next step is they're going to add it to both sides. And then basically they're getting this perfect square trinomial on it by itself on the left side. Okay? So, and then I think there's a typo here, because that negative CA, that should be a negative CA right there. Okay? So hopefully all that made sense so far. Okay, we're just completing this square. And when we complete this square, we technically get, we get x squared plus b over a x, and then let me change the color here, plus b squared over 4a squared equals negative c over a. And remember, because we added that b squared over 4a squared on the left, we've got to add it on the right as well. Okay? And so this turned into that red box right there. It's a perfect square trinomial. Okay, so hopefully I haven't confused you too much. At this point, we are right here, step number 5, right? So step number 5, I'm going to start solving for x. Okay. Well, basically they rewrote that and they put it to the put it at the end of that equation there. So that's really not going to change much. The next step, though, they're going to subtract those two fractions, and of course, when you subtract fractions, you have to have common denominators. Well, the lowest common denominator here is going to be a 4a squared. How do we turn that to a 4a squared? Well, I just multiply the bottom by 4a, and that will give me a 4a squared. Because I did that to the bottom, I've got to do it to the top. Right, so that's 4a times c is 4ac, and that's how we get minus 4ac, because that's a minus. Bottom is 4a squared. It's already a common denominator, so you just write it once. Okay, so far, that's how we got that. Now, it says you're super close. I'm going to solve for x. So at this point, I'm going to have to erase my screen, because that's the only way it's going to allow me to scroll back and scroll down. So let's get to step number 8. Step number 8, oh, hold on one second. We'll go back up to step number 7, show that, then I'll explain how we get to step number 8. So once again, we are solving for x, right? So we're solving for x, I've got to get rid of the second power. To get rid of that second power, I've got to square root everything. Square root everything will cancel out that second power, and therefore you're going to get this on the left side. You'll see absolute value of x plus b over 2a. And essentially, before I get to that, let me just simplify this real quickly. If I'm square rooting that entire fraction on the right, well, I'm square rooting the denominator as well, right? So the square root of 4a squared is 2a, because the square root of 4 is 2, the square root of a squared is a. And then the top, I just leave it as a radical of the square root of, square root of b squared minus 4ac. Now because I'm getting the square root, remember when we get the square root of a positive value, you're going to get the plus and minus version of it, right? And that's why you see the absolute value bars. The absolute value bars is telling you you're going to get a positive version and a negative version of that answer, right? So if you don't even have to think of that absolute value bars if you don't want to, because you already know that when you get the square root of something, like we did right there, you're going to have a positive and a negative value. So we can just jump from step 7 to step 9. So now, x is almost by itself. We just have to get rid of that. And we just subtract that on both sides, right? So that's why, technically, you get x equals, let me erase this here for step 10, x equals negative b over 2a plus or minus square root of b squared minus 4ac over 2a. But now, because they have common denominators, why not just write it as one giant fraction, like we do down there? Okay, and there you go. Voila, there is the quadratic formula. Whew. All right. So that gets you the solution to any quadratic polynomial that you may have. Okay. Let's move to 10-75. 10-75 says to use the quadratic formula to tell me how many intercepts each of these quadratic functions have. If you recall, an x-intercept is a 0, right? It's where it's going to cross your x-axis. It tells you how many solutions you have. It says you do not actually have to find the x-intercepts. You just tell me how many x-intercepts there are. So you can check your work with a calculator if you need to as well. Okay? So if you recall, there's a little trick that you can do where you don't have to solve this all the way. We talked about this in previous lessons. Go ahead and try that, and we'll talk about the results when you come back. All right? So pause the video. Again, you just tell me how many intercepts each of these problems have, A, B, C, and D. Come back when you're done. Okay, so you should have been able to use the discriminant to solve this, right? Discriminant is that square root part of square root of b squared minus 4ac. If you get a positive answer, you'll have 2 intercepts. If you get a negative answer, you'll have no intercepts. If you get a 0 answer, you will get 1 intercept. So the first one, problem A, you would have realized that you had two intercepts. And they're right there. Okay. Problem B, you would realize that there are 2 intercepts. They're right there. Problem C, you would realize that there are no intercepts because it proved it graphically. It doesn't cross the x-axis. And then problem D, you have exactly 1 intercept. Right, again, right there. It is at the vertex of that parabola. Okay, 10-76 talks about imaginary numbers. So it says to consider this equation, 0 equals x squared plus 1. And then it says use a graphing calculator to find the solutions of this. So let's see. Thought I had this earlier pulled up. Here it is. So there's the equation. It says I changed 0 to y on Desmos just so it could show up. So y equals x squared plus 1. As you can see, I don't have any intercepts, right? So we go back to the problem itself. It wants us to solve algebraically. So if we're going to solve algebraically here, right, I'm going to have to subtract 1 on both sides. And I get negative 1 equals x squared. Well, my next step is to square root this. So the square root of x squared is x, and the square root of negative 1 is just the square root of negative 1. All right. So part C says, let's read this together. It says, by the 1500s, people trying to solve equations like the ones above did not have real solutions. Created a whole new set of numbers. This new set of numbers came to be called imaginary numbers. Imaginary numbers were very reluctantly accepted at first. The basic imaginary number is the square root of negative 1, which is now denoted as I. If you have not already done so, find the 2 solutions of the equations of part B. Then verify that they are both solutions to this equation. Then when you do that, try to solve problem D. Okay? So try to make sense out of problem C, and then attempt, we'll do problem D together after that. Pause the video, come back when you're done. Okay, so to answer that question, it's real simple. You recall, if I get the square root of x squared, and I've got to get the square root of negative 1 as well, right? When you get the square root of negative 1, you have a positive and negative square root of negative 1. That's what x equals. So it's asking you to verify, so that's technically 2 answers, right? I have a positive square root of negative 1, I have a negative square root of negative 1. And every time I plug those in for x squared, and I solve, I add 1 to it, I'm still going to get 0. So whether it's the square root of negative 1 squared, if I'm going to square that, I'm going to get negative 1 plus 1, I'm going to get 0. Or if it is the negative square root of negative 1 squared, I'm still going to get negative 1 plus 1 equals 0, right? Because a negative times a negative is still going to be a positive. Okay, so let's go ahead and solve D together. Obviously, I'm going to subtract 81, right? So we get x squared equals negative 81. So when we square root this, I'm going to get, well, what's the square root of a negative 81? You've got to think of this in terms of what can I factor out of a square root of negative 1? What times what equals the square root of negative 1? Well, I have the square root of negative 1 times the square root of 81. Okay, well, we know what the square root of 81 is. The square root of 81 is 9, right? Plus or minus 9. And then, well, now what do we call the square root of negative 1? The square root of negative 1 is just I. So your answer there is 9I. Okay, let's move to the next problem. 10-77 goes back to that equation from problem C that we just looked at the graph of. And remember, there are no solutions to that one. So it says to use a quadratic formula to solve for y equals 0. And then look at the math notes box in this lesson to see how imaginary numbers fall into the organization of the number system. So just a real glimpse at the math notes real quick. The entire number system falls under this complex number system. Complex number system splits into two parts. It's an imaginary numbers part and the real numbers part. Real numbers part is what you've dealt with your entire life up until this point, right? And then we're adding imaginary numbers to it. So when you get a chance, go ahead and look this over. This is pretty interesting stuff. So that is the number system. That means every type of number in the world is organized into this system. Okay. So if you have an equation that doesn't have any intercepts, you want to find what the answers are. You're obviously going to get some imaginary numbers. So I want you guys to pause the video and go ahead and solve this problem right there using the quadratic formula. Come back when you're done. Alright, so I plugged it into the quadratic formula, and this is the answer that I got. 10 plus or minus the square root of negative 20 all over 20. Now, from there, you could simplify it a step further, right? You could simplify the square root of a negative 20. What is the square root of negative 20? Well, you're going to have to break down the factors of a negative 20. Right, so what times what equals the square root of negative 20? Well, the square root of negative 4 and a positive 5. Well, from there I can break down negative 4 once again. So what times what? I crossed out the square root of negative 20 because it no longer exists. What we have is the square root of negative 4 times the square root of 5. So the square root of negative 4 is the square root of 1 times the square root of 4. And again, that no longer exists. Well, I know the square root of 4. The square root of 4 is 2. All right, so my final answer is going to be 2. I have the square root of 5. So 2 times the square root of 5, and then I have the letter I remaining. So you can replace that right there. I can call this 10 plus or minus, and that term is 2 rad 5 I. That would be your final answer if you wanted to take it that far. It's definitely going to be expected of you when you do this in Algebra 2. Okay? And we're going to do one last question here for today. So we're going to skip 10-79. We're just going to wrap this up with 10-78. Okay? And it says, consider this equation, the quantity 7x minus 5 squared equals negative 2. And we've seen this problem in the past in 10-60. What solutions does this have? So if we're going to solve this equation, you already know what to do, right? We're going to square root both sides. What's going to happen when we square root this? So again, do your best, pause the video, come back when you're done, and solve this problem. Alright, so we get x equals 5 plus or minus the square root of negative 2 over 7. Again, if you want to take it to the next step and change that square root of negative 2, you can say 5 plus or minus I square root of 2, or square root of 2 times I. You just got to be careful. If you write it the other way, like this, make sure the I is not underneath the radical, right? So that's why sometimes I like to write it in the front of the radical, like that. So it doesn't look confusing, because again, you don't want it to be the square root of 2I. It's the square root of 2 times I. Okay, all over 7. Alright guys, that's it for today. It's kind of a long lesson. I don't expect you to know how to derive the quadratic formula on your own, but it's very useful to know how to do it. If anything, it allows you good practice with your fluidity and your algebraic skills when you're solving equations. You should know how to solve for imaginary numbers, though. All right. That's it for today. If you guys have any questions, shoot me an email. See you on the Google Meet, or set up a meeting with me. But hopefully I will talk to you guys soon. Have a great day.